Okay, so on the review packet I gave you, problem number 4 is asking you to solve all 3 systems of equations in problem 5104. That's a closure problem, and it's actually asking you to solve these without graphing. So graphing is fine, you can use graphing, but only to check. We're testing you on this to make sure that you know how to algebraically solve it. This problem, pretty confident that a lot of you are understanding this when y equals one thing and y also equals another thing, that you can just use substitution and you can set those two things equal to each other. Now this is a quadratic because I see there's an x squared, and anytime I see an x squared and an individual x, I know that I'm going to have to set it equal to 0. It's not going to work any other way, probably. So let's see. I also see I have a fraction. I'm not a big fan of fractions, so I'd like to get rid of that 1/3 as well. So first I'll set it equal to 0 just by subtracting 2x and adding 2 to both sides of the equal sign. So subtracting 2x and adding 2 to both sides of the equal sign. So over here I'm going to have 1/3 x squared minus 2x plus 3, because I could combine those like terms, equals, and over here now I just have 0. Now I'm going to multiply through because I want to get rid of that 1/3. I'm not a big fan of having that there. It's not going to be easy to factor with a 1/3 there. So I'll multiply by 3, every single term. So 3 times a third is just 1, so I have 1x squared. 3 times negative 2 is negative 6x. 3 times 3 is 9, and 0 times 3 is still 0. And now I'm going to factor that. If you don't remember factoring, I do have a video on factoring. If you go and look at the Chapter 5 skill set in Moodle, you'll see some videos on factoring. But after I've factored this, I'm going to end up with x minus 3 times x minus 3 is equal to 0. And once I have that, I know that those factors have to be equal to 0. Now they're the same thing, so I guess I only have one answer here, and that's that x equals 3. So x equals 3, they only cross in one spot. Part B is a little bit different because this doesn't have y equals something and y equals something. It's actually x equals y squared, which is a sleeping parabola, and x minus y equals 6, which is a line. In this case, I think if I had to solve this, I see that x and y squared can be used interchangeably because they're the same thing. So I'm going to plug in y squared here for x. Otherwise, I'm going to write that exactly the same way because x is y squared. And now to solve this, I would go ahead, notice how I have a squared and I have a single term, which cues me off to set it equal to 0. So I'm going to subtract 6 from both sides. Y squared minus y minus 6 is 0. And then I'm going to factor it. Again, if factoring is difficult for you, go ahead and watch that video, which is one module above in the Chapter 5 stuff. But here I get, let's see, y minus 3 and y plus 2. If I multiply that out, I would have y squared minus y minus 6. And now I'm going to set each of these equal to 0. So y minus 3 equals 0 means that y is 3. And y plus 2 equals 0 means that y is negative 2. And oh, this isn't the only answer. I'm looking for points of intersection. I forgot to do this in A, so we'll have to go back and do that. So when y is 3, x equals y squared, which is 9. So there's one answer. And when y is negative 2, x is negative 2 squared, which is 4. And then I can just quick do a double check with the x minus y equals 6. And sure, 4 minus negative 2 does equal 6, and 9 minus 3 does equal 6. So it works for both of those. Looking back up at part A, I found out that x was 3, but I never found out y, so I better do that quick. I'm going to use this equation to figure out y. So 2 times 3 minus 2 is 6 minus 2, which is 4. And if I want, I can double check it up there. 1/3 times 3 plus 1, that does equal 4. So I know that that's right. So there's the point of intersection, 3, 4. Okay, you can watch the next video for part C.